Hello, everyone. Thanks for joining and also your patience as we get started here. This is the Nashville Tableau user group for June 24th, and we have Sarah Battersby with us. She's a research scientist at Tableau Software. Her primary area of focus is cartography, but she also has an emphasis on cognition. She really just pays a lot of attention to the way people think and consider and get cognition around maps themselves. So she will be able to show us how to do a lot with Tableau and maps. It's a big part of what we're having to talk about today. Her work emphasizes how we can help people visualize and use spatial information most effectively. She's earned her PhD in geography from the University of California at Santa Barbara. She's also a member at the International Cartographic Association Commission on Map Projects. You guys got to work on that name. And is also a past president of the Cartography and Geographic Information Society. Quite the mouthful, quite the accomplishments, and I look forward to seeing what Sarah has to show us. Without further ado, I'd like to invite Sarah to share her screen and unmute herself. And we can get started. Thank you, Sarah.
All right, took me a second to find the unmute button as soon as I unshared or started sharing. So thank you guys for allowing me to come talk to you guys today. You'll probably see the side of my head a little bit because I've got 3 screens going on and I only have a camera on my laptop. So sorry, I'm using the big screen and you can talk to the side of my head. So my name's Sarah. I'm on the research team at Tableau. I'm a cartographer. I used to be a GI science professor down at the University of South Carolina. And most of what I do right now is I spend a lot of time at work playing with maps and trying to bend Tableau to my will. So I'm going to talk today about some of the fun and useful things you can do with spatial data in Tableau. And I'm going to start out with some examples using data from the open data site from Nashville. So just a little framing on this. So I left academia to work at Tableau, partly because I was just really impressed by how easy it was to work with spatial data in Tableau. And I found that a lot of what people need to do with spatial data doesn't really need a geographic information system. And in Tableau, we're going to make spatial data really accessible to everybody for decision making, because as much as I hate to think about it, most of the world is not GIS focused, and a simpler tool can help people get to answers a lot faster. So I've got a few demos that I'm going to go through to show what I think is really the power of geospatial in Tableau and some of the range of possibilities for spatial analytics. So let's go ahead and get started because I know we started up a little bit late. I'm going to start with some analysis on a data set from the Nashville Open Data Portal. And specifically, I'm going to look at the Hub Nashville 311 service requests. So if you aren't familiar with Hub Nashville, I guess residents can use Hub Nashville to submit service requests related to trash, permitting issues, street or road issues like potholes, graffiti, and hopefully the city then puts them on a list of things to take care of. So using this data set, I'm going to use Tableau to start with one of the most basic spatial questions of how is the data distributed? Where are the requests? How many are in various places? And how does that pattern change across the city? So let's take a look at this data set. And I just grabbed it straight from these websites that you can see right now. So first thing I'm going to do is I'm just going to look at how much data I have. I've got about 296,000 requests, so 296,000 rows of data. And what the data looks like, I'll just open up the data source pane and update. So it's just a big old CSV that I downloaded. And it's got a request ID, it's got the type of request, when the request was opened, closed, how it came in, whether it was through a phone call or through an app. We've got a little bit of geographic information like latitude and longitude. We've got an address. We know if the case is open or closed. We've got some good basic information about the data. Now, since we're going to look at this spatially, because we want to understand how these calls are distributed across the city, what I'm going to do is we're going to make a quick map. So all I've got to do is grab my latitude and longitude. So these came in and Tableau automatically recognized them as geographic fields. I'm just going to drop those on the visualization. So I've got those on my worksheet now, and what it's going to give me by default is just this one point, because Tableau really likes to aggregate things by default. So I can break those apart by just dropping a unique identifier on my viz as well. So I'm going to take my request number, which is unique for each one of the requests, and put it on detail. And that's going to let me get to the first basic thing you do whenever you want to see a spatial pattern, which is just, let's just look at where the points are located. And so what we end up with is we've just got a big blue blob. Remember, there are like 296,000 records here. So we might want to drill in a little bit, look at this in other ways so we can understand how these requests are distributed around the city. So one thing to point out is the latitude and longitude were automatically recognized as geographic in Tableau. So I've got my mouse over latitude right now, and there's a little globe-looking icon right next to it. That's what tells you that Tableau knows that this is something it can put on a map really easily. If you don't see that, you know you've got a latitude and longitude, you can just right-click on the field and update the geographic role and set it to latitude or longitude, or any one of the geocoding roles if it's a text string that matches to something like city name or country name. So with all of this on the viz now, let's go ahead and let's look a little bit more at what's in the data. I'm going to take my request type and my sub request type and just drop those on as a tooltip. And I'm going to zoom in a little bit so we can look at the data a little more closely. And I don't know a whole lot about Nashville geography, so I'm just kind of guessing at places that might be interesting. I figured the middle of the map is probably somewhere pretty good. So I can look at any one of these requests, and I know at this particular location, there was a request related to trash recycling and litter. It's an illegal dumping problem. There's a cart service issue, a missed pickup for trash and cart service. So I can get some details about each of these points. And as I zoom in farther, I can start using the base map to look at a little bit more of the distribution. At least with this base map, which is just the default light style base map, I can see where the points are relative to streets. And I get a little bit of context. You know, it looks like maybe there's a park right here. It's a slightly different shade. But one of the things that's cool about maps in Tableau is we're providing a lot of different base maps for you to use. So if you go up to the background map options, we've got right now 8 or 7 different styles that you can choose. Some of them have a lot more detail than others, and all of them are customizable. I find for point level mapping in cities, the streets dataset or the streets base map is really good because it comes built in with a lot of extra context like building footprints where they're available and points of interest. So once this map loads up, you're going to see it's a little bit brighter. The base map is showing a little bit more detail, including park names. And as I zoom in, let's see if we can get some building footprints and maybe some named locations. Looks like I maybe randomly did not pick a great location to get points of interest, but you get a little bit more of that Google map type style where you're going to see, oh, there we go. So here's the new Livingstone Missionary Baptist Church showing up. We've got a restaurant showing up. You know, you're going to have all sorts of additional detail that help you get context for what is at a location, what is around it, how is your data distributed around those locations. And this is all something that came about when we moved over to the vector map box tiles and introduced a lot of new map styles. I think that was in version 2019.1. So one of the new maps that we got a lot of requests for, in case this is useful for your data, we also have the satellite data base map option, which is really nice if you want to be able to see your data in context of what is in that specific location. What do the structures look like? What do the roads look like? And you want more of an imagery look. Okay, let's go back to streets. So that's one way we can look at our distribution, is just add all of the data and then start zooming in until you can see enough of the base map and the data is distributed enough that you can see the individual points. But sometimes you really want to get more of an overview. So if I go back out to the full zoom level, it's really just a big blue blob. It's not helping me understand a whole lot about how this data is distributed across the city. So I might want to go to a different level of detail. And one of the things that's built in Tableau is all of the geocoding roles. So I can look at zip codes, for instance, because that is a geography that is built in to Tableau. This is not something that's coming out of the data set itself, because that's just a CSV. There's no polygon in that CSV, but there is a string that is the zip code, and Tableau can recognize that as a geographic role. So if I double click on my zip field, it's going to go ahead and add by default the centroids of each one of those zip codes. And then if I want to aggregate all of my data into those zip codes, I just have to drop my count field onto color. And it's going to show me how all of those points count up inside each of the zip codes. So now instead of a big blue blob, I get something that's a little bit more useful for identifying which areas of the city have higher requests in the Hub Nashville 311 system. So I know that zip code 37209 had 23,960 requests. Zip code 37013 had 26,754, and so on. I can just go zip code by zip code and look at the details. Now, one thing I want to point out is there are 3 unknowns here. So I get this little marker down in the corner. And if I click on that, I can edit the locations to see what the problems are in my data set. Now I've got 3 problem locations here. One is that I have some data located at zip code 00000, which doesn't exist. I've got some data at a zip code 372515, which is 1 digit too long, but I don't know which one of those digits is the wrong one. And then I have some zip codes at null, so there's no zip code recorded. So this is just a point to note that when you're working with attributes that you're using for geocoding in a data set, there's always a possibility that there may be some errors in it. So I just wanted to open this up and point it out. If we knew what this zip code was really supposed to be, I could just type that value in for the matching location, and Tableau would automatically update and drop those data in that zip code. So here we've got the zip code level data, and that's nice because I didn't have to find any geography for it at all. But we might want to look at the data distribution in other ways, maybe not being constrained to something like zip codes. So another way that you can explore distributions is with the density mark type that was introduced a couple versions back. So here I've got all of the point locations, and I'm going to create what you'll often see referred to as a heat map or a hotspot map. All I have to do is change the mark type down to density. So if I go to the density mark type, what this is going to do is it is going to take all of those point locations and look for where we have the greatest amount of overlap in those points. So for what region, irrespective of zip code boundaries or city council districts or neighborhood boundaries, just with the raw latitude and longitude, where do we have the most data? And what I can do with this is I can see these areas where there's much higher densities. Those are going to show up brighter on the map. I can start drilling into those, and the map is then going to rescale to show you the density relative to the new view. So at the zoomed out level of the city, we had a big hot spot, and as we zoom in, we've learned that most of the kind of the hot area is really targeted to this one very small location. And we can then use the built-in selections in Tableau and just select all of those points that are falling in that specific area. So I know there are 3,400 requests in that very small little area. But this is a good, quick way of taking a look at overall patterns, it's a great way when you have data that really changes smoothly and continuously across space. And what I mean by that is you have data where it's been counted up by just pure location. It's not, I know that there are 12 things in this zip code and I don't know where they were exactly in the zip code. This is where I know that these points can really occur anywhere. And I want to understand how they change continuously without being constrained by artificial boundaries like we are in a zip code. So for instance, I don't know between this zip code right here and the one next to it, 90% of the points could fall right on the boundary between these two zip codes. And I can't tell that because I only get a single polygon with one color attached to it. But with the density mark, I can see more of the continuous, where exactly are the points located. So another way we can look at spatial distributions is with custom geographies. So a nice thing about the data set that I downloaded from the city is, it had things like zip code in it, and I can match those up with geocoding regions. But it also had some other geographies that might have been really interesting to look at, like council districts. So this is, I'm assuming, the city council district for the city. What I could do is also go to the hub, or the Nashville open data source, and grab a spatial data file for this. So I grabbed the the council district outlines shapefile, which is just a table of geographies. And that table has a matching identifier. So the Hub Nashville dataset I downloaded, the CSV, has a column that says, here is the council ID. The shapefile I downloaded has a column that says, here is the council ID. So I can do a real quick join in Tableau. And I just set up this relationship of district ID in my CSV is equal to the district ID in my shapefile. And what that's going to let me do is now use this other data set, this district data set, and it gives me a geometry, which I can drop onto my map. And I'll just add district number to detail. And now I can really quickly sum up how many of these point records fall in each one of those districts. So if a geography outside of what Tableau is providing for geocoding roles is really interesting for your aggregation, all you have to do is bring in the spatial file and connect it up. In this case, I was able to use an attribute in the CSV to do my join. That's great when you have that attribute, but you don't always have that attribute to work with. So another way that you can connect your CSV to spatial locations and aggregate it is by using the spatial join functionality in Tableau. So I'm going to show that using some hexagons because hex bin maps, besides the fact they look kind of cool, they're a nice way to show the same sort of pattern that we had with the density map or the heat map, where we can see more of this smooth, continuous change of the data set across our map. But this has an added bonus where we're going to be counting up the absolute number of points that fall inside each one of these hexagonal polygons. And what that lets us do is really easily link it to other visualizations so that we can explore areas that have high values or low values, or just geographically somewhere that's interesting to us. So let me show you what we can do with this. I'm just going to take the count of number of points. This is my count field. I'm going to drop it on color. And now really quickly, I've done an aggregation, and I can see that the very specific geographic area with the most requests is right here. I could zoom in, look at some detail on the base map underneath. I'll just make this a little bit more transparent so you can see through. So I know that this is an area right around like Union Street and 4th Avenue North. I can see it's near Victory Park. It's near Bicentennial Mall State Park. And I can get all of the geographic context. And I have this polygon that's interactive. So I can link this polygon to other visualizations and say, tell me more about specifically what is happening right here where we have the most service requests of any location. So I'll show you how this gets made. I'll just change the opacity back a little bit so you can see the map again. This is a really simple spatial intersection. And this is probably my favorite feature that we've introduced to Tableau since I've been here. What this is doing is it's taking the latitude and longitude values in the CSV I downloaded and a shape file or a spatial data file of a bunch of hexagons that cover the Nashville area. And I'll say, so I actually generated this hexagon shape file in a tool called Arcgis. So it's a free open source geographic information system. I generated that outside of Tableau. I wrote a blog post on it a few months ago that describes how to make these files. It takes probably about a minute and a half Do it once, it'll take you 10 minutes to do it. The second time you do it, it's going to be crazy fast anytime you need to create some hex pins to use for this type of analysis. So how do I get these two files talking to each other? It's just a join, and it's a special join type called intersects. So I'm using the geometry from the spatial file that I made, all of my hexagons, and I'm having Tableau do a calculation for me, where it's using the make point calculation, which says take the latitude and the longitude in my CSV file and turn them into a geometry, turn them into a point geometry. And once Tableau sees them as a point geometry, then it can go ahead and do this spatial intersection behind the scenes and figure out which one of the polygons from this hexagon data set does every point fall inside. And that makes it so that when I come back into my worksheet, I can get an absolute count without having to have any other way of linking these two files together. It's just, it's just like an Excel spreadsheet and a spatial file. Now I get them talking together, and I can aggregate my data into any of these polygons. So you could also do this, let's say we didn't have a city council district ID in the CSV file that I got for the Hub Nashville calls. I could have taken those latitude and longitude and still joined them into a shape file that had those city council districts, and I would have had exactly the same result, because it would have just looked to see where those latitude, longitude points are and which polygon they fall inside. So once we put our data together like this, we can start making more complex visualizations. So here's our map with the hex pins, and I've added in some proportionally sized pie charts because I wanted to understand the status of all of the requests that have been put in. And each of these are sized based on how many total requests. So I know that the most requests from anything in the data set happens to be property violations. Next is trash, recycling, and litter, then street, roads, and sidewalk related requests. And because I have all of my data in the spatial join, and I have an absolute count for each one of these polygons, I can link these visualizations together to start doing some smart filtering. So I'm going to take this map, and I'm going to go ahead and use it as a filter. So now when I select any one of these locations on the map, it's going to automatically filter to show me the stats on only the requests for that specific area. So we'll take this one because there are a lot of requests here. Now I've filtered down my chart underneath, and I know that property violations are no longer the most common request for this location. It happens to be street, roads, and sidewalk related requests. Or I could pick another location, or even a bunch of different locations. And we can see more about what are the requests in this specific area. I know there are a lot of trash, recycling, and litter requests, and 85 of those requests are in progress still. That's the greatest number. 3 of them have been assigned, and 2 of them have been transferred. So if I want to be able to drill in on locations and understand what are the status of the requests, where do I have a lot of outstanding requests still, or if I want to use this other visualization as my filter, I could look for other patterns like where are the electric and water requests coming from? Okay, it's a much smaller subset through the city. Or where are my public safety requests coming in? Okay, they're starting to be concentrated a little bit more right in this central area. So I could look for specific request types, transit requests, or planning and zoning requests, and then keep drilling in to see where are they, how many are there, how are they distributed, how many still need to be completed, how many are open, how many are closed. I could just keep adding more visualizations to this and drilling in to explore exactly what's happening at each one of these locations. So that's the first thing I wanted to talk about, was just some basic, how can we drill in and explore the broader question of how is my data distributed and what does that distribution mean? Just one quick example, show you something that I made. This is a similar visualization. So this is it's called Get It Done data. This is the same type of data set except from San Diego. This is where my mom lives, and she's always talking to me about how much she hates the scooters. So I used Tableau to build her a scooter tracker. so that she can go in and look at where all the scooter complaints are. And I'll just point out this nice dark blue area. That's pretty close to where my mom lives. And I have heard that she is, I think she was described as a heavy user of the Get It Done program. So I like her to be able to go in and she can say, okay, here are some requests near me. She can click on the link or click on the polygon to see, how many scooter complaints in this particular area. And then I set it up so she can just mouse over and see, what was the date this was put in, when was it last updated, what is the status, who has it been referred to, because she's the type of person who's probably going to want to follow up on it. And I'll just also point out, you can add really cute little custom symbols because I thought my mom would like those better than the default blue square. So I just added in some little SVG scooters because, it's, that little bit of bling is just sort of fun. And actually I realized in this particular example file, I think I've got a link to the blog post I wrote maybe about creating hex pins. Let me just see if I could bring it up just so it's there in case anybody's interested. Nope, these are not right, but if you want indoor floor mapping, I have a blog post on that too. We can talk about that later. I was hoping that old file happened to have them. So I want to move on to a little bit of proximity analysis because it's not always just a question of, how are your data distributed overall. Sometimes it's really important to look at very specific aspects of proximity. So what is near to this location that I'm interested in? So I'm going to look at school locations. So I went to an open data set that came from ArcGIS Data Hub, which is an Esri thing for any GIS folks out there. And they have a data set for public schools. And so I grabbed all the public schools in the Nashville area. And from the data.nashville.gov, I grabbed all the beer permit locations. So these are all of the active beer and beer caterer permits. Now I know a lot of municipalities have regulations on things like how close can different types of liquor licenses be to schools or other minor oriented businesses or churches. And I'll admit that I haven't looked up the regulations in Nashville, but my guess is there's probably some kind of restriction where they shouldn't be within, offsite beer sales, probably not within like 100 or 200 or 500 feet of a school. So we're going to use this as just kind of a nice proxy problem for figuring out what is nearby and how can I explore that in Tableau. So the data sets I have, I've got the Nashville area schools. So I've got geometry for that. This came in as a spatial data file. So I can just double click on my geometry field and it's going to populate in. I'm going to go ahead and add the name onto tooltip. And so I know, and the feature ID, there we go. So I know there's Haynes Middle School, we got Nashville Collegiate High School, Stratford High. I've got all the schools. At least hopefully I've got all the schools. And now I want to know something about what is around each one of those schools. So what I'm going to do is I'm going to build out a buffer around each of them. So I could just look at the school itself, and I'll just add those same things that I had on before. So I've got my school geometry, and I'm going to zoom in so we can see the impact to what I do a little bit more easily. I'm going to use this buffer calculation that we've created. So I'm going to create a calculated field, and let me make this a little bit bigger. So I'm going to use this calculation where I just say I want to create a buffer. So this is going to create a circular polygon around each one of my points in my data set. And I'm going to buffer around the geometry. So I have to tell Tableau which data set to use or which part of the data, the attribute. I'm going to buffer it by, I'm going to use a parameter for this because I want it to be dynamic, but you could just type in a value. So I'm going to buffer it by a parameter called buffer distance. And you have to tell it what unit you want, feet, meters, miles, kilometers. And I went ahead and created a parameter for that as well, just so we can change them easily and look at the impact. And I'm going to say, okay. Now I'm going to take that geometry and I'm going to drop it onto my visualization. Notice those little tiny dots just got a lot bigger. But because my buffer is defined based on a parameter, I've got a parameter over in the upper right corner of my worksheet here. And I'm going to change it from 1,000 feet to 500 feet. And those circles just got smaller. And now I'm going to change it to 250 feet. And they just got a little bit smaller. And now I'm going to change my buffer unit. And this is going to be really crazy. I'm going to change it from feet to miles. So each one of these schools is now going to have a circle drawn around it that's 250 miles. Yeah, it's pretty exciting, right? But I'm going to zoom out. I'm actually going to make it even bigger. Let's make it like 2,500 miles. And that's going to be totally crazy. But I wanted to show you that this is no longer a circle. Why is this no longer a circle? This is a map projection problem. So we use the Web Mercator base map. If we drew a perfect circle, it would not be a true buffer around these points, because on Web Mercator, the distances get stretched out as you move farther away from the equator. So what we're doing is, I'll just make it simple. We're doing the right math behind the scenes instead of doing the math that's going to give you a perfect circle that is not actually 2,500 miles, in each measurement direction. Okay, so now we got our schools. We've got these really nice buffers around each one of these schools. We need some data for them to play with. We're going to look at the beer permits. So I've got data set with beer permits. So this is all of the active beer permits. I'm going to put the permit number on there, and we'll just grab business name and permit subtype so you can see a little detail about it. Here's Slim and Husky's Pizza. They have on sale beer. Here's some off sales at Kroger. Wild Wasabi has on sales. So we know some details about each of these locations. You may be looking at these places, you're like, oh my gosh, that is the worst place to go buy beer. But they're all just locations. They're all just locations to me. So what we need to do is, it's great that we've got these as two separate data sets, but I need them to talk to each other. And this is where the power of spatial analytics comes in and what we've got built in Tableau. I'm going to show you the finished worksheet, and then I'm going to show you how it's built. And I probably won't build it back up just because we don't have a ton of time, but I can give you these workbooks after the fact if anybody wants them. So this is the beer permit locations and those school buffers combined together with a spatial intersection in Tableau. I then add in a couple extra little calculations so that I can have this really nice color encoding. And I can use that parameter that I created. So right now, all of those red points are beer permits that have been issued that are within 2,500 feet of a school. If I want to look at 500 feet, I just changed my buffer distance. All of those buffers are going to change size. All of the color encoding is going to change. And only the points that fall inside of those buffer polygons are going to be highlighted. That also means that I can create other visualizations using the knowledge that this particular beer permit number is within the location or within distance of a school, and I can start running off some statistics. How many permits near each school? What kind of permits near each school? How many violations for any of those locations? How many of them close to schools? How many of them far away from schools? What would happen if we said we want to make sure that there aren't any beer permits within 600 feet? How many are impacted? What if we want to know about 200 feet? How many are impacted? All of those analytics would be possible. So I'm going to change this back out so it's just a prettier picture because I think the 500-foot buffer is kind of boring looking. But let me show you how this is built. So this is just getting the two data sources to talk to each other. I've got my beer permit locations and my Nashville area schools as two separate connections. And I'm going to double click because with 2020.2, we changed to a new data model. But to do a spatial intersection, you kind of go back into the old data model. And the way you do that is just double click on your data source. I'm double clicking on my beer permit locations, and it opens up this little dialog so I can see what has been joined to those beer permit locations. So I'm doing a full outer join because I always want to see all of the permits and all of the schools. And I'm doing some calculations in here. So I've got a join calculation on my CSV that says, turn my latitude and longitude into a point, because a spatial intersection requires you to use a geographic point, and a CSV doesn't have a geometry in it at all. So we have to make one of those. And I want it to intersect a buffer. So I just create a buffer around my school geometry, and I'm hard coding and saying, give me a 1 mile buffer. The reason I do this is because you can't currently use parameters in join calculations. So I picked a value that I thought was the largest value I might possibly want to use. And this is going to find every beer permit that is within 1 mile of any school. And then on my worksheet, I pare that down so it links to my dynamic buffer. So let me just go back to my beer near schools and show you the special calculation that does that. Because I can't use a parameter in that initial join calculation, I just create the second calculation that then says, essentially, am I near a school or not? So for any one of these beer permits, I look at what is the distance between the geometry for my school and the geometry for my beer licenses. And this is just another calculated field I made. Instead of typing in make point latitude longitude again, I just went ahead and made that a calculated field. And then I tie it to the parameter for buffer distance, or I tie it to the unit that I'm using for my buffer. And then I compare it to the parameter that I have for the buffer distance. Because the join itself is saying, tell me everything within a mile, but I don't care about everything within a mile on my viz. What I care about is everything that's within this buffer distance that is dynamic, that I am now controlling on my worksheet. And this gives me an attribute that will always be in sync with that parameter. So I can use that near school attribute and I can color encode based on it. And it's going to give me true, I'm near a school. Null, I have no idea where those are. I'll be honest with you, I have no idea why null comes back sometimes. And false, these are all of the beer permits that exist but aren't near schools. I make sure I drag my true locations up to the top, and then I've got this really nice visualization that is going to stay in sync anytime I change my buffer value. I can put that together and get a nice dashboard of here are all of my my schools, here's all of the beer permits that are near them, and here are some ways that I can interact between them. I've got the count of, say, Hume Fog High has 22 beer permits near it. I know that that's one of the highest counts that I have. I can just select it and have it highlighted on the visualization. I'll show you one last thing that's kind of fun that you can do to put these all together. We have this nice feature called set actions. So set actions make it so you can interact with your visualization in a new way and add things and remove them from sets really quickly. So I took that same data source, same two data sources of the schools and the beer licenses. And I've got my schools with these little blue star logos. I realize it's probably, I'm going to change the base map because it's probably a little bit busy to really be able to see those blue stars on top of the base map. Okay, so I've got my blue schools, my blue stars for schools, and I've got this one orange star, which is my selected school. I set this up with a set action, so I can now dynamically pick any one of these locations, and it's going to just buffer around that one location, update my visualization. Oh, accidentally clicked on the wrong thing. It's going to update my table over on the side and tell me which schools, how many licenses near each school. So let me pick a school that actually has some licenses near it again. My laptop is a little bit slow and crufty right now, but I'm interacting directly with the school markers, and it's updating which buffer gets drawn. It's tied to that same parameter, so I can then change the distance of my buffer, and it'll dynamically update and tell me all of the licenses that are near the school and maybe some attribute about them. And so this is my, if you can read this text, this is my really exciting random attribute that I created, which is really just a random number generated for each one of these that's being summed up. But it could be something like number of complaints against this location, total sales, any sort of attribute that you have that you might want to add up. And if you want to look at the difference between one place versus another, all you have to do is pick your school, give it a second to update, it'll redraw that buffer, it'll give you all of the new rundown of everything that is within distance of that. So if this is pick a location and see all of your competitors, pick a location and see all of your customers, you can do this completely interactively and tie it together with some parameters so that you can then change the size of that buffer and get new analytic results. So I think there's only about 10 minutes left. I had a couple other demos that we can talk about exciting things like that sometime later. Maybe I'll come back and visit you guys in your tug later on. Since we're all remote for possibly a while, the possibilities are endless. So that's what I have to show to you today. I want to see if anybody has any questions real quickly. And I'm happy to provide any of these workbooks if anybody wants them.
So there was a question from Michael Lane early on about doing proximity or near join detection with buffers. Something like point-to-point join, but to the nearest 1 meter or so many degrees, that sort of thing.
So I'm not sure I'm entirely following the question, but it sounds like it's about it's about a buffer join, I think, and proximity analysis. Anything that you can create a buffer around. And right now we can only create buffers around point locations. But if you can create a buffer around it, you can identify any points that are inside it. And if you're doing something like it has to be a self join, you can do that just fine. So if it's I've got a data set of customers and I want to know the distance between, I want to know every customer within a mile of another customer, I could just join those two data sets to each other. I don't know if that gets at the answer, but I'm totally open to people emailing. If you want to ask questions, we can probably sort out what the answer would be.
People do have the ability to unmute themselves if they want to ask a question.
Right. I had a question as well. When you were showing us the hex plot, would there be a way to do some kind of like dual axis or something where you could have the hex, but then in the background also have the district lines drawn or the zip code lines drawn? I know zip code, like you could do the map layer, but I was thinking of like a data driven.
No, so if you wanted both like the hex pins and the zip codes on the same map, yeah, you can do that with a dual axis map. You just have to, it would probably just be an adjustment to how you put your data sources together.
Gotcha.
Yeah, I could probably do a quick, I can't do it with the districts because I don't have them in this particular data set, but we could probably do something equivalent and look at, say, just like the point locations on top of it. I think you just take these things off and then we'll drop our latitude and longitude on, and probably wherever the ID is for this.
Yeah.
Yeah.
Zip code would probably get the point across.
Yeah, so I'll let my computer churn on that for a second, but I'm just adding all of the point locations. And so it would be the same process of just creating a dual axis map. And instead of using a point geometry and the polygon geometry, you would be using 2 polygon geometries.
Gotcha.
So you can add multiple polygon geometries like you can in GIS?
Sort of. So we don't have just like layering functionality at this point. I mean, this is something we get a lot of requests for, and it's something we are actively working on. But right now, the way that you would do the equivalent of layering is we can support dual axis mapping. So you can get 2 different data sets. You just kind of have to fiddle around with the join. I have a lot of details on that on my blog post. I have this dual axis mapping post that goes through like all of the different ways that you can combine from CSVs to shaped files and putting them together so you can have multiple, at least 2 layers on your map.
Cool.
And let me see if this is just kind of a fun example since the question came up. It's a nice way to try and fact check your data. So I used the zip code attribute in the data set to aggregate all of the points, but it turns out the data is actually kind of cruddy. So I did a dual axis map with the zip code boundaries and all of the point locations. So I could go through and look at things like where are all of my null points located. So these aren't getting counted up at all in any of the zip code level data. Now my computer's just sort of spinning. But one of the interesting points, you can see those dark spots on the map where there are no zip codes. Turns out there are actually points in there. They just don't have zip codes attached to them.
Mm-hmm.
So it's a nice way to fact check when you're just using an attribute out of your data set. It may not actually line up with the real spatial in the data set. Another thing I found, there were some point locations that were given zip codes. So this pink spot right here is given zip code 37211, and that's clearly not in zip code 37211 because I think that is the zip code way over here on the right.
Mm-hmm.
So it's being counted over here in one map, but it would be counted over here in a different map. One thing to just point out, spatial data is really freaking weird a lot of the time. And for the person who asked the layer question, I'm hoping that was you probably giggling a little bit because sounds like maybe you're like, yeah, I work with spatial data and it's weird.
Yeah, yeah. I have a not quite as much of a geographical background as you do, but it's up there.
Yeah, you're going to spend, yeah, just like, you know, making any visualization, you'll spend 90% of your time cleaning the data. Cleaning spatial data is going to be like 107% of your time. And then you get your extra 3% of your time for your 110% effort on the viz to actually do fun stuff.
Yep.
I don't think we have time for it, but I would love to see your process for finding map data sets. Like the stuff you're showing me with, you know, what's available for Nashville, I had no idea. I'm sure there's more.
And for the stuff that's native to Tableau with their like spatial mappings, I just have a problem right now where I get a country and I get a city, but there's a Springfield in every single state. So it's not very helpful. So I'm kind of trying to figure out how I can work with that.
Yeah, so if you want to send me an email offline, I am pretty easy to find. My email is just sbattersby. Or if you go to the Tableau research website, research.tableau.com, and let me see if I can, I'll just bring that up. I think it's got my email on it, and I will drag my window over. So if you go, yeah, on the people page, I will show up. My email is just first initial and then last name @tableau.com. So one of the things I'm particularly interested in right now are these problems with geocoding where you've got things like I've got a city and I've got a country, but I need to be able to get, say, like the state name in between so that I actually get it to map. So that's the kind of problem that I'm actually digging into at the moment. And I've got some scripts on my end that I can run and potentially help you do a little bit of cleaning or at least find the pain points. So feel free to reach out.
Thank you.
So is there any functionality similar to ArcGIS that we can turn a street name into a dot on a map? Is that available?
Yeah, so I think you're asking about whether we have any like built-in geocoding functionality to go from something like an address to a latitude and longitude. We don't, but there are a number of free geocoders that are available, and there are some pathways that you can go to take big tables of data. So I've written a couple Python scripts that do that, and I've been doing it in Tableau Prep. I've actually got some blog posts related to that as well, and some scripts up on GitHub, which you'd be able to just grab. Some of them use things like either Mapbox or there's a US Census geocoder. And at least for Mapbox, you do need an API key, but it's free up to like a bajillion geocoding points. I have, I run the same data sets over and over and over again as I'm testing, and I have never been charged anything. So for most cases, you can geocode, but you have to do that outside of Tableau.
Can you geocode in ArcGIS and then import it into Tableau?
Oh, if you geocode it in ArcGIS and it gives you a latitude and longitude, just bring that data straight on in.
Cool. I thought so.
Yeah, I mean, we love latitude and longitude. We love most of the file formats that Esri supports. Even in 2020.2, I didn't show this demo, but we also support grabbing data services. So you can go in to anybody's ArcGIS hub, and if they have their data as a data service, you can just copy that service and open it up directly now. So I can copy and then connect to data Esri ArcGIS server, and I can paste in that connection string, and it will bring in the data source. And it takes a second because what it's doing is it's downloading it and extracting it behind the scenes so that it doesn't have to keep hitting the same data source or keep hitting the same server. But we'll extract it, bring it in, and then you can work with it just like any other spatial file source in Tableau. So you could do intersections, you could do anything you want. So this was just grabbing all the neighborhood boundary definitions from New York City from their ArcGIS data service. And I'm happy to answer more questions if people want. Just reach out over email, and we can continue to chat. Thinking about maps is kind of what I do all day, or at least on a good day. It's what I get to do all day.
Great, thank you, Sarah. This was fantastic. I've learned lots, and I'm sure everyone enjoyed seeing how proficient you are. I think we have a brief announcement about next month. Jim, do you have the name of the person who's agreed next month? Is that available?
Yeah, Bridget Cogley is going to speak next month, and Bridget is going to speak about how to make a very impactful dashboard, how to take really disparate things and put them together and come back with something that's really kind of fabulous looking for a dashboard. She's really very good at that. I think she's a 4-time Zen master, so Bridget knows what she was doing.
Great. I'll look forward to Bridget. Late July, would that be? I think that's the 29th. That's the last.
I don't have my calendar open in front of me.
Yeah,
it's the last Wednesday of the month, and yep. she's already booked for that. Sarah, I want to thank you personally. If you could send me those 2 data files, I'll see that they get to the group.
Yeah, I'll send you some assorted things and some links to blog posts that have come up.
Okay, very good. And just by the way, the princess arrived, and
and are you going to bring her in for a showing right now before we all log off?
I was going to, but she's being fed.
Okay, well, I will look for the Slack photos later.
And they will be out there. Thank you so much. I look forward to when we can all be together again.
Agreed. Thank you, Sarah. Thanks, Jim. And thank you, everyone. I'm stopping the recording now.